Okay, so give me the other decreasing one. Give me the other decreasing one. Well, get me all, okay, and then raise your hand if you've got it. Got it? Okay, Mona, the decreasing one. Okay, is everybody there? And then the increasing one, Mona, or someone else? Let's get someone else. Amy? Yeah. Amy, increasing? Okay, Manisha, you got it? You know what we are doing? You don't know how to get it, or you didn't get it? The increasing one? Well, remember the increasing one is these green ones here that I show you. Okay, so you know what this point here is. What's the x value there? 0. 0. What's the x value there? You just found it, right? You just found it. So from -1 to 0, it's increasing. And then it's increasing from there to there. What's the x value here? 1. What's the x value way out there? Infinity. So it's increasing from 1 to infinity. And also from -1 to 0. Is everybody okay? Does anybody need help in doing this stuff? You got it? Ray? Okay. Anyway, is everybody okay there? Manisha, are you still not very certain? Amy? Got it? Okay. Okay. Maximum, minimum, and what I call local and global. Okay. So get this graph down, and then I'll start kind of explaining. So you guys got the title there? So notice that there are two functions there, okay? There's gx and an fx. Okay, got it? Okay, so let's take a look at the red one first, okay? That's this one here. This point here is called, actually that point there is the absolute minimum and also the local minimum. And I'll explain the difference to you in a minute, okay? It's more apparent when we look at the other graph. Okay, when we look at the other graph, it's much more apparent. Okay? If you look at the blue graph, then this point is called the relative maximum, and this point is called the relative minimum. For the blue graph, there is no absolute maximum and absolute minimum. Okay, and this is what the differences are. Okay, notice that this point here is called relative because there are other y values that are bigger than these, aren't there? Okay, see that? I mean, if I were to go on my graph here, doesn't that have a bigger y value than this does? Okay, that's why this is called relative, because only in its neighborhood is this guy the biggest value. You guys get me on that? Same thing is true with this guy here. This is a relative minimum, because if I were to go on this graph way down here, do you see that the y value would be less than this y value? Kylie, you're kind of looking in a daze. You okay? All right. So that's why this is called a relative min, okay? Because just in this hood, this is the minimum, okay? Somewhere else, there are numbers that are less than that. The y values are less than that. Mona, question?
Okay, so if you had a graph like that, so all the higher points, like all of them would be relative.
Well, yeah, Yeah, it depends. I mean, if you have, for example, a sine wave, a sine function like this, then you can see that these are relative and global because there is no number that's bigger than that number, the y value. Right? So in this case, the relative is the global. Just like it is in the just like as it is in the red one. See how in the red one, this is the relative and the global minimum. There is no y value lower than that. So in some instances, the relative will be the absolute as well, or the global. Okay, absolute and global are the same thing. Okay, they are synonyms. Is everybody okay on this? No? Did I hear someone say no? Thomas, are you gaming there, boy? Are you gaming? Your thumbs are moving like they're gaming thumbs. Oh. Okay, you guys do this then. Okay, you guys do this. So everybody get a graph like that? Okay. What you want to do is you first want to find this minimum point here, okay? So you're going to go second, calc, number 3, minimum. Move the cursor over to the left of the minimum point. Hit enter. Move it to the right of the minimum point. Hit enter, enter. And there's your minimum. So your minimum is at x equals, so this is what you want to write down. Okay, since it's a point, it's going to have xy pair, so minus 1.5275, comma, negative 7.1285. Round to the 4th place, okay? Round to the 4th place. Then go find your maximum in this one. How are you going to go find max? Noah, how are you going to go find max? Second calc, and max is number 4. Okay, move the cursor to the left of the maximum point. Bring it kind of closer, okay? It doesn't necessarily have to be too close. And then move it to the right of it. Hit enter, enter. And after a little bit of computation, max comes out to be equal to 1.5275 and 7.1285. Right? So this is your min, this is your max. So in this interval here, is the function increasing or decreasing? Decreasing. So it's going to be decreasing over the interval. What's the x value? Nice, negative infinity. And the x value here at this point, I had it there. Negative 1.5275. Is everybody with me on this? Eric, you got that? Okay, and then you've got increasing, negative 1.5275 to positive 1.5275. Is everybody with me on that? Inaki, are you here? Hi. Yeah. And then the next interval is going to be increasing or decreasing? Decreasing, and that's going to go from. Sorry? Positive 1.5275 to. Why negative? Remember, these are x values. These are x values. Again, all these intervals that we talk about for increasing and decreasing are the x values, not the y values. Okay, so your x value for this graph, as this graph is going out forever and ever and ever, is going to be positive infinity. Is everybody all right on this stuff? Looks like you're in a daze, man. Sean, had a smoking weekend? Kind of dazed out? Okay, I'm done. So there are issues with the grading. So those people who got grades out of 10 instead of 20, you need to bring that out to me and I'll tell Nate about it.